So now, Dick, I would like us to discuss about climate itself and science itself. And to start with, maybe we could evaluate, if you could tell me, points of agreement. What can be said about climate at our decennial scale, facts with which everybody could agree, if any?
Yeah, I mean, there are a lot of things one could agree on, although the interpretation of the agreement might vary. So, nobody is arguing that CO2 is not increasing. It's increasing. I think there's a very substantial agreement, not total, that the increase in CO2 is due to industrial activity or cement mixing or God knows what. There is no disagreement that CO2 absorbs in the infrared. There's no disagreement that a priori adding CO2 should cause some warming.
And the sum is important because
yes, of
quantitatively there are a lot of disagreements.
It could be negligible.
Mm-hmm.
And indeed, if the usual metric is doubling CO2, and the usual agreement is if you double CO2 and kept everything else constant, you might get 1 degree of warming. Until recently, 1 degree of warming was considered negligible. And then all of a sudden politics enters. Arbitrarily, it's decided that another ½ degree is the end of the world. This is stupid, but that's what you have. You suddenly have this funny feedback. So the politicians decide that another ½ degree is terrible, and then you have scientists saying, well, if you don't do this, you might go over a ½ degree, although they don't suggest it's the end of the world, but if the politicians want to treat it that way, okay.
Okay, and also a point of agreement is the fact that the Earth has warmed during the last
that you
century.
say, and it's probably true, because if nothing else, we were in what was called the Little Ice Age, and there's no question something happened around 1800. From about 1500 to 1800, alpine glaciers were advancing. And then, beginning around 1800, a little after, alpine glaciers in the Alps and elsewhere began retreating. So something happened. On the other hand, there's agreement that whatever happened before 1950 was not due to CO2 because the increase was too small to do anything. So, strangely enough, I think there has to be widespread agreement that climate changes without us.
So this is for agreement. Now disagreement starts at the middle of the 20th century.
Disagreement is actually more extensive than people think.
Mm-hmm.
So, for example, I think certainly I disagree with the notion that climate is defined by one number. I mean, I'm interested in the temperature difference between the equator and pole, why the tropic. The question, actually, there's disagreement about the question. But then, even within the narrative of greenhouse warming, of course, there are arguments about sensitivity.
So maybe you can distinguish.
Sensitivity is saying, we said if you just have CO2 doubling, you get a degree. Many of the models suggest you might get 2 degrees, 3 degrees, 5 degrees. And that is because in the models, there are what are called feedbacks. That when you warm a little, something else changes that causes you to warm more. None of these are rigorous. They assume water vapor will increase, and on the other hand, measurements from space suggest that this is not working. So there are plenty of arguments about it. One of the more subtle arguments, in a way, is Le Chatelier's principle. That, long-lasting natural systems should be dominated by negative feedbacks that prevent them from going awry. And yet the climate narrative is built on the assumption that nature is evil, it's out to punish us, and whatever we do, it'll make worse. This is a very peculiar Manichaean view of the world.
So you talk about Le Chatelier's principle, but of course mainstream climatologists know about this, so they have an answer. In general, they say that feedback the negative feedback is less powerful, and that's why we consider them as positive feedback.
The whole issue depends on assuming there are positive feedbacks.
The
trouble is none of them have ever been shown.
So do you have an idea of what is the sensitivity, the climate sensitivity? I mean, if we double CO2...
I'm pretty sure doubling CO2 will give you a half degree.
Half a degree?
Yeah.
Okay.
I've said this for 30 years. There are a lot of reasons for it.
So could you explain?
Yeah, sure. First of all, if you make a simple energy balance model and you take the increase in CO2 and increase in all the other greenhouse gases, and you ask what sensitivity would you need in order to match the observations, you always get a very low sensitivity. The answer of the people who wish to say it's bad is, well, of course, there were aerosols, sulfate aerosols, that canceled the warming, so you don't see it all. But by now, the aerosol people have shown that, there's a limit to how much you can do with that. Mm-hmm. And so, with the current limits on aerosol, it would be hard to match the observations with more than 1 degree. And it's easy enough with a half degree. In addition, there are all sorts of subtle things. So for instance, if you have a very sensitive climate, the warming or change in temperature takes a long time. And so for instance, if you have a volcanic eruption, and if you have a low sensitivity, then what happens, you have 2 years or so when the temperature is cool, and then it's restored to normal almost immediately.
And this is what we observe.
If you have a very sensitive climate, then you have the same first 2 years, but then the relaxation is very slow. You don't see much evidence of that. So, if I look for evidence that there's a high sensitivity, outside of models which enforce it, I don't see it.
So you talk about models. Maybe you could we could elaborate on this. What actually the models?
Well, the models are, initially they're reasonable attempts to replicate a physically coherent system. There are problems. You are essentially modeling fluid mechanics. You're modeling fluid mechanics where you have the oceans and the atmosphere. Each of them is what is called multi-phase. You have water vapor in all its phases, you have salt, you have this. So it's a complicated system. To make matters even worse, no one has ever proven that you can numerically model a fluid and converge to the right answer. So there's a kind of hope that you can do this. But then you have the additional problem for the atmosphere and the ocean that you're dealing with at the largest and planetary scales, and at the small end you're dealing with millimeters. And even today with the most powerful computers, dealing with such a range of scales, which immediately means you need to have very fine time resolution and so on, it's still far from possible. And so what do? Well, you take the sections that you cannot resolve and you approximate them with what's called parameterizations. That's how you deal with clouds. But we don't know enough about clouds to parameterize, so you have a lot of freedom to fool around. And you had one example which I thought was quite lovely. There's a man at the Max Planck Institute named Lindzen. He's actually, I think, Danish. And he was working there with a man called Bjorn Stevens, who is the main modeler at Max Planck in Germany. And Lindzen was explaining how they work. He says, we start out by choosing the sensitivity, and then we fool around with the clouds and so on to make it work consistently with what we observe. But you know, when you come to what's observed, what are they looking at? They look at this, quote, temperature record, which is really a record of the so-called temperature anomaly. And if you take the same model and say, is it putting the seasonal averaged highs and lows in the right place? No. It's not getting regional climate, it's not getting that. So I think the modelers like to have one number, because it's easy to match one number if you adjust the clouds and adjust this. If you actually looked at the numbers regionally, you'd see the models are not working.
And do you think it could become useful at some time, or?
You know, it's a good question, and I don't know the answer to it.
Are we really far away from?
I don't think they'll ever be good for long-term forecasts. I think there are intrinsic problems. For short-term forecasts, I would say today weather forecasts for 2 days are pretty good. But we all know, you know, when you look at your phone and look at the forecast, it's wrong about 30% of the time for 2 days. And the skill diminishes, and by the time you're at 7 days, everyone agrees it's pretty close to zero. Mm-hmm. I remember for years you'd be on panels to assess the Weather Bureau's progress and so on. And I remember every year you'd get the same thing. It is, we've now advanced forecast skill to 6 days, 7 days. And then you come back 10 years later, and what have we done? We've advanced forecast skill to 6, 7 days. It seems like there's a kind of barrier there. Mm-hmm.